Hi students, welcome to this particular online lesson, which is the first video for the concept on mole concept. So there's a total of actually 3 worksheet or notes you need to accomplish. So this is being divided into 3 different parts of videos. So we're going to start with the first video today, which is just on the first formula for mole concept. Before we go on further, let us just define this term mole first. I know to a lot of us over here, mole can refer to this very cute animal over here, the mole, or it can refer to the thing that you find on your skin, right, the black mole that you see over here. Right? But in chemistry, mole actually refers to something that is very different. So what exactly is the meaning of mole in chemistry? To understand that, let's first take a look at how do we usually count items. What do I mean by that? For instance, if you were to go to the market one day, right, and you want to get this, say this tray of 12 eggs. So instead of saying 12 eggs, what you can do is you can say, can I have a dozen eggs, right? That's what you do. And if I have this 3 over here, you just say that, okay, can I have 3 dozen eggs, for example, right? Instead of saying that, oh, can I have 36 eggs, for example. If I have more, likewise, you just say that now, can I have 9 dozens of eggs, right? Instead of saying that, oh, what is 9 times 12, so on and so forth. So you realize that in our daily life, we actually use such unit like a dozen to help to represent a bigger value, say 12 eggs, we say a dozen, right? So similarly, right, in chemistry, we actually use this term mole to represent a known number of particles. Now, what is a particle? Okay, you have learned previously that particles can refer to either atom, ion, or your molecules, right? So basically, a mole is just a unit to represent a certain number of atoms, ions, or molecules. What is this certain number? Actually refers to a total of 6.02 times 10 to the power of 23 particles. So you see this standard form over here, right? This is actually a very huge number. And this number is discovered by this person known as Avogadro. So this is how it looks like. This very handsome man over here is Avogadro. So we call this number 6.02 times 10 to the power of 23. We also term it as the Avogadro constant. So it tells you that, okay, every 1 mole, there will be this number of particles inside. And the unit for mole is actually represented over here by mol. So how big is this value of 6.02 times 10 to the power of 23? If I were to write this out, right, in numbers, right, it actually looks like this. Yeah, so many zero. If you were to ever count it from starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, until you count finish the entire set of numbers, right, it will actually take you at least 1,910,000 billion years to finish counting, right? So that is a very huge number. Because it's such a huge number, we don't like to say that, we don't like to use it in the way to describe how many particles we have. That's why chemists came up with this term known as 1 mole. Right, so once I say that 1 mole, immediately everyone know that you are referring to 6.02 times 10 to the power of 23 particles. And that's the importance of this value. It's just like a dozen, right? Instead of saying 12, you say a dozen. It's an easier way to represent the number of things that you're talking about. There's a total of 3 different types of calculations or formulas that you must understand. Today we'll focus on the first one, which is to calculate based on molar mass. So what exactly is molar mass? I'll explain a bit deeper while we look at the notes itself. Alright, so now let's take a look at the notes. Alright, so now let's take a look at the first set of notes in this component of mole concept, and that's L2, mole and molar mass. Now, let's just quickly write down what we talked about just now using the slides. So, as a recap, what exactly is a mole? A mole is what we call a unit that's used to represent a known number of particles. What is this number of particles? Do you recall for 1 mole? Yes, it's 6.02 times 10 to the power of 23 number of particles. This is a very important number that we call Avogadro's constants. So this number of particles, right, these particles can either be your atoms, molecules, or ions, or even your subatomic particles such as protons or neutrons. And of course, the symbol for mole is mol. Right? That was what we talked about just now. So what we're going to do in this set of notes is we are going to explore the first formula that we need to know to calculate number of moles. Because we can talk about, oh, this is how many mole, this is how many mole, but we don't even know how to calculate. And how can we even describe something in terms of number of moles? So the first formula that you need to know today is that The number of moles of a substance can actually be calculated by dividing the mass of the substance, okay, by its MR or AR. Now, this mass, right, do take note that it must be in grams. Right, now, of course, right now you might have noticed something that's familiar, which is these two values, which is your MR as well as your AR. So, do you still recall what they represent? Yes, as some of you can recall from your previous set of notes, AR refers to the relative atomic mass, while MR actually refers to the relative molecular mass, right? And so depending on what is the formula of the substance, what kind of substance we are looking at, we can use the MR or the AR to calculate it. Okay, so what is the importance of this? Because this MR or AR, right, is actually, it has the same value as something that we call the molar mass. Now, what is a molar mass? Basically, right, a molar mass is the mass of 1 mole of the substance. Okay, so basically with this mass, this AR/MR, you actually represent the mass of that 1 mole of the substance. It's the same numerical value lah. And if you take the total mass of the substance divided by the MR or AR, right, you can calculate how many moles there are. So let's take a look at one example first. Alright, shall we? So how do you determine the number of moles of iron that's found inside this mass of iron? So looking at the periodic table, you know that iron is actually represented by this symbol Fe. Right? And so using the formula, number of mole equivalent to the mass divided by, in this case, because it's just Fe, right? Because it's just Fe, so we are looking at the AR. So it's the mass divided by AR of Fe. So what is the AR of Fe? With that, you have to go back to your periodic table and take a look at where exactly is iron. Iron is actually found over here. You remember which set of numbers refers to the AR? Yes, it's the number at the bottom. So the AR is equivalent to 56 in this case for iron. Right? So let's go back to the notes. So what is the meaning of that? Basically, it tells you the mass in this case is 0.196 kilograms, right? Let's first change it to the unit that we want. And if you recall just now, I mentioned that the unit must be in grams. So if I change 0.196 kilograms to gram, I will end up with 196 grams. So therefore, the mass is actually 196 grams. 196, and the AR I found just now was 56. By doing this, I can actually find out what is the number of mole of iron that was present inside this 0.196 kilograms of iron. And the answer is 3.5 mole. Now, of course, the unit is important, and you realize that mole, right, can actually have decimal point, and in fact, you realize that mole sometimes you also need to round it off to 3 significant figures. Now, remember that mole is just a representation of a certain number, in this case 6.02 times 10 to the power 23, right? So you can have 3.5 mole, nothing wrong, because it's just 3.5 times 6.02 times 10 to the power 23. So there's no issue with it having that decimal. So let's take a look at another example first. What is the mass of 0.02 mole of hydrogen chloride? Now, the same idea works over here, but you need to do a bit of changes in the formula. First of all, hydrogen chloride, formula of HCl. Okay, so thinking about the same concept, now I'll give you the mole. Okay, I give you the mole now, and I want to find out what's the mass. Okay, the formula that we taught you all just now is number of moles is equivalent to mass divided by the MR or AR, right? So, what's the implication over here? Basically, the formula still holds true. Number of mole is equivalent to the mass over, in this case because it's HCl, right? We're looking at the MR of HCl. You know what's the number of moles? Is it given in the question? Yes, it's 0.02 mole. So, if I sub in the value, right, I can find out that 0.02 mole is equivalent to the mass over MR of HCl. You know what's the MR of HCl? Okay, some of you will know that actually you can refer to the periodic table and you'll end up with this. Mass divided by 1 plus 35.5. And with a bit of manipulation of the equation, shifting this value up over here, you actually end up finding the mass is actually equivalent to 0.02 multiplied by 36.5. It actually gives you a mass of 0.73 grams. Now, what I did over here was actually just that I changed the equation a little bit. So if you take a look at the two equations that I used, right, both of them are still about number of moles, giving you mass over the AR MR in this case, right? So it's still a number of moles divided the mass divided by MR or AR in this case, right? What we did though was that we actually reshuffle the equation a bit for the part 2, right? Because depending on what we want to find, we can actually change the equation to help us find what we want, right? This is something that you need to take note of. It's just like in math, how you change the numerator and denominator, you bring it to the left side or the right hand side of the equation, for example. Alright, so that is what we have to talk about for this particular concept. Now, we would like you all to try this out by yourself for question A and B. Right, there's two questions given here. Take some time to try it out, and if you are not sure, right, please come back to school so that your teacher can revisit the topic with you. Okay? And of course, you notice that for part B, right, you must first know what is the formula for magnesium oxide. Right, if not, there's no way that you can apply the equation to in this case. So this formula, in order to work it out, you have to go back and understand how does the ions come into place in this entire ionic compound. Alright, so with that, we have actually come to the end of this first part of the video on mole concept. So as you can tell, right, what do you really need to know for this particular topic? First of all, you must understand how the equation works, right? Then you must, through practice, you should be able to learn how to manipulate the equation to help you to find out what you want. So what is the main thing that we want to cover today is to help you to understand that, oh, look, I can actually calculate the number of moles if I have the mass of the substance, and all I need to do is just to use the periodic table, find out either the MR or AR, and just divide the mass with this particular value that I'm seeing. Alright, and that should be able to tell you how many mole of the substance you have. Right, so get that through practice. Don't be afraid to make mistakes. Alright, and that's all for the first part of the video. Thank you.